Now we move on to triangle OXY. In triangle OXY, you can see first of all that OY is equal to OA plus AY. That's pretty simple. Okay. Now in triangle OXY, let's apply Pythagoras theorem. Pythagoras theorem, as all of you must be aware of, Pythagoras theorem says that the hypotenuse is resultant vector. So the magnitude of it will be just R. Hypotenuse, the square of hypotenuse is equal to the sum of square of base and perpendicular. Base in this case is OY. Now OY is OA plus AY. OA is A vector. So we can just write it as A. And AY, as we have found here, is B cos theta. A plus B cos theta is this complete OY. Now this is base. Square of the base plus square of perpendicular. Perpendicular is XY. XY is B sin theta. It is simple trigonometry. So this is the Pythagoras theorem that you have been using since time immemorial, maybe from class 6th. Okay. Okay, let me rub this portion. Okay, now all you have to do is expand this bracket. This is A plus B whole square, which is A square plus B square plus 2AB. And this is B square sine square theta. Now B square sine square theta and B square cos square theta, and you know what you have to do next. You can write it as A square plus 2AB cos theta plus B square sine square theta plus cos square theta, and you know what this is. This is 1. So you can just rub it off. B square into 1 is B square. So you have now a mathematical formula for finding the resultant vector R square. R square is equal to A square plus 2AB cos theta plus B square. So the resultant vector is really the magnitude of resultant vector is root over A square plus 2AB cos theta plus B square. So this is how you will find the resultant vector. Now remember, what is theta here? Theta is the angle between the vector. I have taken this angle as theta, and this is really the angle between the vector. Angle between A vector and B vector would be found out by bringing A vector and B vector tail to tail. So you have to extend it here, and the angle would be this theta. So theta is the angle between the vector. A and B are the magnitudes of the vectors. So you use this formula and you get the resultant vector. We'll solve certain problem and we'll get on with this. But before that, this is just the magnitude of resultant vector. Vector, you got to have the direction as well. Now direction we can get the direction of our vector as angle phi with respect to A vector. But first of all, let's calculate phi. Mathematically, let's find phi. R we have found out as R is equal to root over A square plus 2AB cos theta plus B square. Now that is the value, the magnitude of resultant vector. Now tan phi, we are looking in the triangle OXY. Tan is perpendicular upon base. Perpendicular is XY, which was B sin theta. And base is OA plus AY. OA is A and AY is B cos theta. Now A, B and theta would be known. If we know two vectors, we know the magnitude of the vector and we also know the angle between the vector. So A, B and theta are known quantities if two vectors are given. And from here we can calculate phi. Phi would be tan inverse of this. So once we know phi, we know the direction of R vector, because we know the direction of A vector. Fine. If we know the direction of A vector, we just have to add an angle phi to it and draw the resultant vector. So So we know the direction of our vector as well. So this would help to get the magnitude of a resultant vector, and this would be helpful in getting the direction of resultant vector. Now you have to use the formula properly. It is b sine theta upon a plus b cos theta. If we use it the other way around as a sine theta upon b plus a cos theta, then this angle phi that would come would be angle phi with respect to b vector. Now this angle phi is angle phi with respect to a vector, and so you have a formula like b sine theta upon a plus b cos theta. If you use a sine theta upon b plus a cos theta, then this angle phi would be respect to b vector. So you have to just be careful on that. Okay, now let's get handy with some problems. Suppose we have two vectors like this, 5, 5, whatever the unit be, the magnitude is 5 and direction has been given. So we have to find the resultant of these two vectors. Let's use the formula ruthlessly. The resultant vector r is root over a square. A square is 5 square plus 2ab, 2ab cos theta. Theta is the angle between these two vectors, and the angle between these two vectors is 0 because these two are parallel. If you bring them tail to tail or head to head, the angle would be 0. So cos 0 plus b square. Just use the formula and get the answer. And it would be a good moment if you have forgotten what is cos 0, what is cos 30, what is cos sine 30, what is cos 60, what is cos 90, what is sine 30, what is sine 90, what is sine 45, what is cos 45. If you have forgotten those angles, the value of the cos and sine and tan for special angles that you studied in class 10, it would be good if you pause and memorize. If you know it very well, just go ahead and solve this. This would be cos 0 happens to be 1. So this is basically a square plus 2ab plus b square. So this is a square, a plus b whole square. If you know the formula, a plus b whole square is equal to a square plus 2ab plus b square. So here the angle is 0, cos 0 is 1. So the formula actually becomes a square plus 2ab plus b square. That becomes a plus b whole square. So a plus b, under root of a plus b whole square is a plus b. So this is 10. So when the vectors are parallel to each other, we simply add them. They are additive.